Hello. Hello, everybody. I know that we are all still a little trepidatious about going out during COVID, so I appreciate you all showing up. It looks like a really healthy group to me. I recently heard the expression, we are the first generation to experience the impacts of climate change and the last generation that can do anything about it. And my friend Holly Rowan uses the expression, the sea is rising, but so are we. My name is Casey Schulberg. I'm the Collier County Waterkeeper, so I really want to thank you all for coming. We're here on the 22nd day of the second month of the 2022nd year. It all seems kind of historic, and it is historic. We are in historic times. We are in cataclysmic times. We're in times when we all have to lean in and be at the top of our game. We're all busy. We're all juggling a lot of balls. We've got to take the kids to the park or see your grandkids or shopping, whatever. But there's one ball that if we take our eyes off it, we do so at our peril, and that ball is Mother Earth. So we need to really pay attention to this issue. My job tonight is to get out of the way and hear these brilliant minds talk and educate us all. So I'm going to just pass the baton to our group in just a second. We have a surprise guest tonight, Dr. Mike Savarese. So I don't know whether you all know Mike Savarese, but he's pretty well known in the region. Mike is the Distinguished Professor of Coastal Resilience and Climate Adaptation at Florida Gulf Coast University at the Water School. Dr. Savarese has been part of FGCU's faculty for over 25 years. He holds a PhD in geology from the University of California, Davis, an MS in geology from the University of Rochester, and a BS in biology and geology from the University of Rochester. Mike's teaching and research interests concern the history of environmental change in coastline settings, appropriate, particularly in response to human development, climate change, and sea level rise. Mike is also the principal author of the Adaptation of Coastline and Urban Natural Ecosystems, more commonly known as ACUN, the report that many of you may have heard about. So, ladies and gentlemen, please welcome Mike Savarese.
All right, thanks, Casey. Casey introduced me as a special guest. I viewed myself as a warm-up band for the true special guests. I'm only going to talk for 5 minutes, and before I do that, I just want to give a special thanks to John Capis and to Hal Wallace for being here tonight. They're two very prominent people with wonderful histories. I don't know John as well as I know Hal, so I'll say some very personal tidbits about Hal. Hal has really been an inspiration to me personally. I don't know if he knows this or not, but I wasn't his student, but he was my mentor nonetheless. And he basically, through one of his PhD students, sort of retooled me to do the kind of geology I've been doing now that's hopefully is helping Southwest Florida. So I owe a great debt of gratitude to Hal for that. So, and Hal, I also share his passion and his drive to use science to best inform decision making, and I think that's one of the best things we can do as climate scientists or geologists is to provide the best science available so that decisions can be made with that information. So thank you for that, and thank you for letting me speak for just a few minutes. Let me start this up. I just have a few slides. I'm not wearing my glasses, so that means I can barely see. I was going to make a referral to The Marvelous Mrs. Maisel. Does anybody watch that show? Mm-hmm. Okay. No? Yeah. Lost analogy. So I'm sort of the warm-up band for Shine Baldwin. Anyway, I thought before Hal and John talked to you about bigger picture things, I thought it might be worthwhile to get a sense as to what's happening here on the ground in Collier County. How are we dealing with our climate change preparedness as we're moving forward? And it's an area where I've been very actively involved with lots of people. I just wanted to show you this kind of roadmap. This is kind of the roadmap for preparedness. If you are trying to help a community deal with the effects that climate is sending our way, you really want to follow this pathway. The context is understanding the problem. Vulnerability assessment is about understanding where you're vulnerable, when and where the problem areas are likely to be. You're going to use that then to design some adaptation strategies. And then you're going to use those strategies and implement them and make the community that you're living in more resilient. Collier County has been very involved in stops 1 and 2 up till now. The county's done a really good job of contextualizing the problem. A whole variety of stewards and managers and civic leaders have been involved in understanding the problem. And at the moment, we now have a package of vulnerability analysis tools that can help Collier County understand where its vulnerabilities are. And that's sort of what I'm here to talk to you about oh so briefly before I turn it over to the more important people. I just wanted to let you know about a number of the efforts that are underway. The first one up on top is this modeling tool package called ACOON, which stands for the Adaptation of Coastal, Urban, and Natural Ecosystems. This is a NOAA-funded effort that's now coming to closure, and it produces a number of tools to look at what Collier County will look like in the future as sea level rise continues and as storms become more intense. And that package is already being used in a variety of capacities to understand Collier's vulnerability, and I'll show you a couple of examples of the products. The other effort that is just really getting underway and is yet to be fully developed is a second NOAA-funded project, which is called creatively ACOON Plus. It's the same kind of thing, looking at vulnerability, but rather than vulnerability with respect to seawater coming over from the leading edge, it's about vulnerability to freshwater, the water that's coming from the other side from precipitation. When that set of tools is ready, Collier County will have in its hands a complete package of vulnerability analysis tools to do the adaptation planning and implementation as we move forward from here. I also wanted to note that through the Water School, we've been very involved in providing technical and scientific guidance for the entire region, not just Collier County, but all of Southwest Florida, the 3 counties and all of the cities. And one of the things we're embarking on now as these NOAA-funded projects are moving forward is we're now developing sort of a catalog of what we call climate indicators. How has climate changed here on the ground? What does it actually look like? What do the data show? And then what kinds of effects are we already seeing with respect to those changes? And that'll be ready probably by the end of June of this year. ACOON is a modeling package. It's very complicated. It's actually beyond my pay grade. I really don't understand it, frankly, all that well, because I'm not an oceanographer, I'm not an engineer. The bulk of the work is being done by people at the University of Florida, at the U.S. Geological Survey. Some people from FGCU are also involved. But in essence, it models inundation. How is the landscape likely going to respond as sea level goes up and as storm surge occurs on top of that higher sea level? So it provides glimpses of what the future looks like with a number of sea level rise magnitudes at a number of different times in the future. So we're able to look at the moment, we're able to look at what 2030, 2060, and 2100 is likely to appear as a response to sea level rise and as storms become more intense as we move forward into the future. It also couples with an economic impact tool, which actually looks at property damage, the cost of property damage associated with those conditions. So there's a way to look at this also from an economic perspective. And then the last bulleted item here, we're also able to look at how the coast is going to change its shape as we move forward in time, because the change in the topography and the morphology of the coast will influence how the water moves over the landscape in the future. So that's the sophistication behind ACOON. Let me just show you an image. This is actually a web-based tool, so eventually it will be available to the public. At the moment it's available to managers that are using it in professional capacity. This is what 2060 looks like under a sea level rise magnitude of 1.8 feet. So sea level 1.8 feet higher than it was in the year 2000. Okay? And this is what the landscape would look like assuming a 1 in 100 year flood event occurred. So a storm, a catastrophic storm, on top of a 1.8 foot sea level rise. And in essence, what you're looking at here is base flood elevations. It's color-coded. You can see the blues are about 1 feet to 3 feet. That's 1 to 3 feet of standing water on the surface. The hotter colors, the yellows and the oranges, between 10 and 14 feet of standing water on the surface, assuming this 1 in 100 year flooding event occurs on top of a 1.8 sea level rise. Now, this data, the capabilities of this modeling is very granular, so you can zoom in to within the size of a fraction of a block. You can look at individual structures, so it has wonderful, wonderful resolution and can be used very effectively as a planning tool. I wanted to just to let you know that the good news is these tools exist, and if you're like me, you know, you go to Home Depot, you buy a tool, you bring it home, and you never use it because, you know, you just want to have the tool. A tool is great as long as it's being used. The good news is it's already being used at Coon. The city of Naples is using it to look at the effectiveness of its stormwater management infrastructure. I'll show you an image of that in just a moment. The Naples Botanical Garden, you're probably all familiar with it, one of the gems here in Collier County and in the city of Naples. The botanical gardens have taken on a conservation effort where they're going to conserve tropical plants and actually cultivate them on their land. Well, before they cultivate them, they want to know where's the best place to plant them. Where are the places where plants are growing now that are threatened that need to be moved sooner because they're in more vulnerable areas? And then the third way it's being used presently is we've got together a collection of historians and archaeologists that are looking at Collier County's cultural assets, archaeological sites, Calusa Native American sites, post-colonial sites, and how they're likely to be threatened as we move forward in the future. So, again, it's very powerful and can be very informative. Here's an image that was used to sort of tempt the city of Naples to use this for their stormwater assessment. You can see the little red areas, the red polygons. They represent drainage basins within the city of Naples where they're having engineering problems. They're places where they want to invest money in improving their stormwater management engineering technologies. This is what 2030 looks like under a medium sea level rise, a 0.7 foot rise in sea level. And what you're seeing on this landscape, mostly in blues, okay, is nuisance flooding, sunny day flooding. So in 2030, just a few years from now, as sea level progresses to a 0.7 foot rise, these neighborhoods are going to experience this nuisance flooding with as much as 8 to 25 times a year frequency, okay? And so you can see the red areas that are targeted for engineering improvement. Some of them are more vulnerable to this nuisance flooding than others. So it's a way of guiding limited resources and how monies are spent. And just wanted to say thanks. So that gives you a sense of how Collier County is progressively using this kind of information to hopefully make us a more resilient community in the future. So thanks.
Just a question. We're going to take all the questions at the end, so we'll hopefully have time for a robust Q&A. Thank you.
You're welcome.
That is sobering stuff. Yeah, that is. I got a glimpse of this 2 days ago, thanks to Paul and Sally Walliver, and this is really kind of astonishing, remarkable, and terrifying at the same time. But it's important that we have this information, that we gird ourselves. Also important that we try to stop the problem at the source, because mitigation is all well and good. We have to mitigate, we have to armor ourselves, but it's more important to solve the problem at the source so that we don't have as great a problem as we do. A little bit of housekeeping, we're filming this, so the film will be ready in about a week. So thank you for that. We'll let you know. Thank you, Richard Ponton, the director of the Lorenzo Walker Technical College Media Department, and Araceli, who's filming. Thank you. So John Capis and I first met, although we had corresponded, when the Citizen Climate Lobby and we at Collier Freedom hosted a climate change workshop in 2018, to which John came and Hal came, and that's how we got things started. And then we got Mike's reference, we got the band back together the following year for a screening of the movie An Inconvenient Sequel, and both John and Hal spoke and addressed a Q&A after that. So we've worked together a couple of times. I have enormous respect for them. And John does so many things, it's hard to keep up with him. He runs 2 nonprofits. He was on the board of the Watershed Council. He was on the board of Calusa Waterkeeper. He kind of seduced me to come up to Calusa Waterkeeper, and he's a Kissimmee Waterkeeper, and he's just doing so much that it's hard to keep up with him. So it is my pleasure to introduce to you now Dr. John Capis.
I'll start a timer here so I don't go too long-winded. Well, I've really enjoyed working with KC over the past several years. When I first arrived here in the mid to early 1990s, I came with a priority to work on water issues in direct linkage with climate issues. Because as you go through the higher education process, particularly in my discipline, agricultural engineering, you have a keen appreciation for the role that energy and climate plays in food production, not just in this nation, but globally. So I had been attempting to get the various water groups, water advocacy groups, even the University of Florida, where I was faculty in Immokalee, to look at these two issues in direct linkage. But people's eyes would glaze over. They wanted to focus strictly on the water aspects as separate from the climate aspects. But as people are increasingly appreciating, that is simply impossible. But KC got it, and when he came over to join Harrison Langley in the Collier Waterkeeper program, and hats off to Harrison for selecting KC to help lead this program. But KC established climate as a co-equal priority with water quality in the mandate for the reincarnation, the next stage of Collier Waterkeeper. So not only is he doing that here, but because we traveled together to the climate conference in Glasgow this past November, he did a briefing series, live briefing series that was shared with waterkeepers all over the world. He interviewed waterkeepers from all over the world on their climate aspects, their climate issues, and made a tremendous impact. So the 350 waterkeeper organizations around the world, headquartered in New York City, are basically taking their cues and their leadership from KC these days. So that's a tremendous accomplishment. And it is not. Because I know, because for years I've been working with them and trying to get them to do something like this and had no success whatsoever. KC steps in and presto, things start to happen. So, I'm representing not only Kissimmee Waterkeeper, but an organization called Campus Climate Corps, and I'll try to explain a little bit about both. So, Kissimmee Waterkeeper covers the watershed extending from basically downtown Orlando all the way to the shores of Lake Okeechobee. Now, when I came down here in '94 and '95, I was one of the founding members of Caloosahatchee River Watch, and I used that as my faculty extension program, much to the dismay of the farmers who assume that every ICAS faculty is lock, stock, and barrel owned by them and should only focus on their priorities. But I felt that to better address the water quality issues of the agricultural sector, we needed direct communications and interaction with the urban sector and the entire population of the watershed. So that is how I structured the program. Then, once we converted it to Calusa Waterkeeper, then I turned my attention back to the Kissimmee Basin, where I'd done my master's and doctoral research on hydrology. Now, Campus Climate Corps is not a 501c3 on its own. Instead, it's a program of two other 501c3 organizations, Intelligentsia International and Alpha Epsilon Lambda. And in fact, Kissimmee Waterkeeper is also a program of Intelligentsia International. Now, Intelligentsia International is basically a group I started in college, and it was with Soviets and Chinese, and long story that's still unfolding quite tragically today. But we changed its name from American Soviet Cooperative Exchange to Intelligentsia International back in the very early 90s. And since 98, I've hosted 500 university students in LaBelle for internships on environmental topics and community service topics. Typically, they stay anywhere from 2 to 4 months, some as long as a year. And the photograph you see in the lower right is a group of students we hosted in 2015, primarily French students, as they were preparing for the UN Climate Conference in France, in Paris. They were helping prepare for the youth aspect of the UN Climate Conference. Now, the other organization, Alpha Epsilon Lambda, is a National Graduate Student Honor Society, and we have about 40 chapters across the country. Been a little neglectful in increasing that number in recent years, but hopefully with the new Campus Climate Corps program, we can develop both the Honor Society Network and the program for undergraduate and graduate students at universities throughout the country. So student organizations can help create change. And I would hope that each of you here this evening, as attending is great. You know, it's great that you're here, that you're helping support the Collier Waterkeeper program and increase your knowledge about the issue. But what's very important is that you leave with a commitment to help solve this problem, help humanity better deal with what's coming. And I personally believe that we can do that best by working directly with the younger generations. So that's where I tend to, just like Hal and just like Mike, focus my time and attention. Now, as I mentioned, we've been working with the UN Conference of Youth each year, in addition to the Conference of Parties, the diplomats meeting. So we've been sending students to these events and setting up exhibits and doing workshops. But we're very cognizant of the impacts. When you fly across continents, you are having a direct impact on climate. So it's very important that you choose your travel and your purposes very carefully, and we do that. And what our objective in sending students to these meetings is to leverage their presence virtually to communicate the content of these UN meetings to students all across the United States. So we, since 2015, have been focused on virtual participation, and we even did a research paper showing how a virtual research poster session compared to people flying to a venue can save 95% of the carbon impacts. And we designed a conference that we hope to implement in it both on-site and virtual format at universities across Florida and across the country. And we've developed various outlines for sessions for those conferences. Now, as I said, water issues are directly tied to climate. And let me just give you one example. Here you see the Kissimmee Basin, and you see all the watersheds that contribute to the Lake Okeechobee. And as you know, the Southwest Florida water quality is heavily influenced by the runoff that comes down from the Kissimmee Basin into Lake Okeechobee, down the Caloosahatchee, down the St. Lucie, and into our estuaries, and generates severe toxic algae blooms. Well, they've been working on reducing, and in fact that was my research, best management practices for agriculture to reduce their nutrient impact on our waters. We've been working on that for 30 years to reduce those nitrogen and phosphorus loads to Lake Okeechobee. But it was largely intractable. It had been sitting at about 500 metric tons of phosphorus going into Lake Okeechobee every year. Then Irma hits. Irma was affected by climate. It was much more pervasive, a greater depth of rainfall over a larger area than is typical of our hurricanes. And the effect that had was that the water managers had to store that water in the upper basin. And that the Kissimmee Basin, it's primarily used as agricultural pastures, cattle pastures. These are heavily fertilized, a lot of waste loads that accumulate. And there's certain assumptions that water managers make that a certain amount of that phosphorus will be retained in that soil permanently. But Irma reversed all that. Because they had to store that water there for so long, it caused a change in the soil chemistry. Changed it from high dissolved oxygen content environment to an anoxic environment, which disassociates the phosphorus from the soil particles. And then when you open those gates to release that water, all of that phosphorus came with the water, such that in post-Irma, that water year, they had a double. It went from 500 metric tons to over 1,000 metric tons. So that shows you that the climate will overrule anything you think you might be accomplishing in water quality. So you must address both simultaneously. So how did we get here on the climate issue? Well, when we retain old technology to feed profit and consumption, we get ourselves into trouble. You know, we basically build high-value infrastructure, and then we like to milk it for everything it's worth. So if we build a coal plant, we want to use that coal plant and fully depreciate it over its life cycle of 30, 40, 50 years, rather than disposing of that still valuable asset and turning to a new technology. And that's, you know, a function of our economic system. And this problem was obvious in the 80s. In our department, you know, the graduate students, we'd sit around and we'd talk about these things. I remember in about 1984, we were just starting to get university students coming from the People's Republic of China. We'd always had people coming from Taiwan, but the People's Republic, those students were new. And we knew that a boom was coming in China. They were a minor player on the carbon emissions back then. But we knew that that would change in the coming decades. So it was obvious that we needed to transform our energy and our food production technologies rapidly so that when we went to export that technology to developing nations like China, that they would use the new technology, not our old technology. Well, we missed that opportunity. They developed using our old technology, and now they are a dominant factor on the climate. They also suffer the harmful algal blooms. We think it's bad here. In China, you could practically walk on their algae blooms. It's just atrocious. So this graphic here shows cumulative climate impact emissions from various countries since 1750. And we're the leader. We've done far more. China's, you know, closing very quickly. Former Soviet Union, Germany, UK, Japan. So these are really the nations. We are the ones responsible, largely, for the current situation on climate. Not that other nations aren't also contributing, but we bear the primary responsibility for getting us here, and thus we have a primary responsibility for getting us through this. Now, looking at the larger scale, and this would apply to water, this would apply to climate equally. If you want to say, where does this come from? What's the basic formula that describes our impact upon the environment? You could say it's population multiplied by per capita consumption and divided by sustainable technology. So as you increase population, you're going to increase the harmful impacts upon the environment. As you increase per capita consumption, you will also increase those impacts. But if we develop sustainable technologies, we can reduce those impacts, still with a high consumption rate and a high population. Now, population can be a little deceptive. We think, well, in this nation, we're only having very few children. Therefore, the problem largely comes from nations that are having larger numbers of kids per person. Whereas here, the average may be under 2, approaching 1. In other nations, it's still 4 and 5. But when you do the math on per capita consumption, we still have a disproportionate impact. But where population comes in is as these large existing populations that have low per capita consumption now are over their lifetime looking to increase their standard of living and their per capita consumption. That gets us in far more trouble than the differential in birth rates. And energy. The energy is really the key to it all. Not just, you know, the gasoline you put in your tank or the light switch that you flip at home, but the energy content of everything in our society, everything in our world. And it's somewhat deceptive. You know, we think it's just greed and ignorance. No, it's not just greed and ignorance. There's a greater biological foundation to this. And Hal, you know, studied under H.T. Odom, was heavily influenced by the research at the University of Florida, who developed this maximum power principle that states that systems, biological systems, self-organize to maximize their consumption of energy and their production of work from that energy. So what we are experiencing as a society isn't just what we would call greed or ignorance. It's really rooted in biology. So what it means is we have to work very quickly and very hard on changing our energy practices and our energy systems overall in our economy. It's very important to start quickly because there's a time lag. There's a time lag in any new technology. Now, if you look at this graph, this shows the deployment of solar photovoltaics, solar panels, starting in 1997, going until I think the data ends in about 2019 and then or 2020, and then I projected it forward. And you can see this rapidly increasing deployment of the number of gigawatts of solar capacity. So we would think, well, wow, we're solving the problem. And we've been solving the problem for many years. But in fact, that's not the case because of a second graph. And this is what's called the energy payback break-even time. And that's, in effect, the number of years the solar panel has to run, to operate, to make up for the energy that went into producing and deploying that particular solar panel. Well, back in 1998, that energy break-even point was 10 years of operation. In other words, that solar panel didn't really yield any net greenhouse gas reductions until 10 years of operations. But through technological innovation, not only in this country, but with the assistance of the Chinese as well, we've driven that down to now where the best solar technology has an energy payback period of less than 1 year. But because of what I mentioned before, fully depreciating existing assets, you've got old production plants for solar panels that are still operating on that 10-year technology rather than the newest technology. So that yields a somewhat complex curve, and depending upon how you get from that 10-year down to the 1 year, I have a couple of hypothetical curves, but I think the 2023 curve is the absolute best case scenario with the industry, and I found no actual published research on this, and I'll continue to look, and if I can't find it, maybe we'll get some students to work on this. But in your first years, you're actually making the greenhouse gas problem worse because you're building more and more of these 10-year deficit pieces of infrastructure. But once you've developed the technology sufficiently, and once you've ramped up deployment to where you're getting enough every year and increasing that deployment every year, then that curve tails down and hopefully you quickly get to a net greenhouse gas savings scenario. So I think the best case scenario for solar photovoltaics is next year it will finally become carbon negative globally. But what's more important is the fact that this applies to every piece of technology out there, whether it's something we're already developing or something we might come up with, some rabbit out of a hat that scientists might come up with and begin to create new technologies. There will be similar lags in benefits that occurs. That's why it's so important to invest early and invest sufficiently in these new technologies. Not only is because of the lag, we have to replace our current energy consumption with renewables. But I'm a firm believer that we are going to need far, far greater amounts of energy than what we're consuming now. Because not only must we make our current consumption carbon negative, but all of the adaptation and resiliency measures that we're going to undertake are going to consume even more energy. Similarly, we're going to find ourselves in a case where we need to begin sucking that carbon back out of the atmosphere. That will take immensely more energy. So replacing our current energy consumption with renewables isn't enough. We're going to need far more energy, and it's going to have to be clean energy, and we're going to need it fast. Now, this is one aspect of what we call ecological economics. Basically looking at our economy, all of our products and services, and doing proper holistic calculations on what goes into it. What are its impacts upon the environment, climate, water, etc. And I did a study like that on sugarcane ethanol back in 2012. Basically trying to demonstrate to the decision makers that sugarcane ethanol made absolutely no sense whatsoever. But it sounds good, people make a great pitch for it, but the fundamentals just are not there. And we have to have programs that can uncover these deceptions to make sure that people really understand the impacts. Now, there are some sugarcane models that do yield net energy, and perhaps don't have as severe externalities on the water quality and the biodiversity and other fronts, but you've got to calculate the hard numbers. You can't simply allow yourself to get sold a bill of goods based upon some slick presentation. It's got to be grounded in fact. And that's what ecological economics can provide you. Now, there are other metrics, life cycle assessment that does a similar calculation. But the important thing to understand is it's not just about accountants, it's not just about engineers, it's not just about scientists. All of the disciplines that are represented in an economy, in a population, at a university are necessary to begin addressing these problems. Because as we've seen, we have technologies that can address it, but up to this date, it's been the social science and the political science, the human behavioral aspects that have been the limiting factor. So it takes the participation of all professionals throughout our society to help address these problems effectively. So that's what Campus Climate Corps is about. We're working on developing these conferences at universities across the country. We'd like to see a program like that at FGCU. We did a trial run at University of Florida. In addition to doing the Waterkeeper broadcast, we did student broadcasts, and we think we're in a great position to begin hosting these conferences at universities across the country starting this November. So thank you.
This has got to be hard because I'm sure you're biting your tongue or sitting on your hands about all the questions you have. There are so many issues to this problem. Social justice, John touched on it slightly, and Mike Savarise's program has a layer to talk about the disadvantaged people in Collier County and how they're going to be struck or harmed more or disproportionately more than other people who might be wealthier and move around. And John, at COP26, there was a lot of talk about loss and damage for the less developed people, less advantaged people. So that's another whole issue that we need to deal with. And it's definitely going to get worse before it gets better. The question is, will it get better? And the question is, when does that curve happen? And how much worse does it get before we start to rein this in and try to get a grip on the situation? So our next speaker is Dr. Hal Wallace. Hal is, talk about early adopters. I know he gave a talk here on climate change in 1981, and he's been working this issue for 40, 50 years.
I gave my first talk here in Naples on sea level in 81.
81, yeah. And so Hal has an extraordinary resume. I mean, I can't cite all of these things. He's currently professor and chair of the Department of Geological Sciences. He was a Cooper Fellow at the College of Arts and Sciences from 2010 to 2013, 71 to 92. He was a faculty member at the Marine Geology and Geophysics at RSMAS. and in geological sciences, the College of Arts and Sciences since 1992. I went online and looked at Hal's resume this morning. It's 44 pages long. Mine is 3. He has been either the chief author or co-author on more than 50 peer-reviewed articles, and he's just a huge figure in this sphere. So it's really my pleasure to introduce to you folks, and we have to plug in the HDMI cable, Dr. Hal Wallace.
Going that way. Okay. Oh, it's not quite ready. Thank you. Do I need the microphone, or is this okay?
Okay.
Thank you. I'm honored to be here, and thank you for coming on this beautiful winter day in Florida. And I want to preface everything I say with the fact that Lynn and I live in Coral Gables, and we love it there just like you love it here, and we're going to live here as long as possible. Sea level is going to move us on our way at some point, but I'm not suggesting you sell tomorrow. But I think you should be careful how you decide your defenses and other things like that. Well, let me start by saying that climate change, of course, is burning fossil fuel. The human-induced climate change because of burning fossil fuel.
We need the mic.
Thank you.
The climate change, the human component, is because of burning fossil fuels, creating an excess of carbon dioxide that goes into the atmosphere. And that's the climate change, that's what we all think about. But as the previous speaker said, it's also about the number of people on Earth. And I was born, like maybe some of you were, in 1942. And there was less than 2 billion people on the planet. And now there are almost 8 billion, 4 times the number of people. Miami and Naples were little towns back at the beginning. And that's important to understand. And it's also important to understand that the number of people on Earth are, in fact, from the less developed countries, even though we, per capita, do a lot more, as John said, a lot more of burning fossil fuels and so on. But this other diagram sort of shows the same. You see the population increase, and you see the total energy consumption skyrocketing. And it's not slowing down. And you can see we did get hold of the energy per person, but we have more and more and more people. In the 60s, we were always talking about population problems. We don't talk about that in universities anymore. I don't know why. Because it's not popular. Because of this increase in energy consumption, which until now is almost entirely burning fossil fuels, a little bit of nuclear and so on, we have warmed our planet. Those gases capture the back radiation, longer wavelength back radiation of the sun's energy, and turns it into heat in the atmosphere. And that has warmed our atmosphere and our ocean. And we've warmed by about 1 degree Celsius, a little over, okay? And that's the reality.
Wow.
That's not up for negotiation. If we look to the future, which UN's Intergovernmental Panel on Climate Change does, this is the number of days that they anticipate we could well be at above 90 degrees, a number of days more than we are at present. And you can see it in South Dakota, they're going to have a month more of days above 90 degrees. And in peninsular Florida, we're going to have more than 2 months of days. We often didn't worry down on the coast in Florida about too many days above 90 degrees. But you can see where we're headed, and this is going to be a different world. That's just one thing. This is what we were talking about at the Paris Accord. How can we keep the atmospheric temperatures from going 1.5 degrees above the pre-industrial levels? We're already a degree up. And at the recent Glasgow conference, they were deeply concerned that we're not going to be able to hold it to 1.5 degrees. We're probably going to go at least to 2 degrees and maybe more. The funny thing is, if you look at this diagram here, the component of the extra heat that's in the atmosphere is only about 2% of the total extra heat created by burning fossil fuels. Over 93% of that heat is transferred to the ocean, the shallow ocean and progressively to the deeper ocean. Okay, and a little bit's gone to heat the earth and to melt ice. But if you really want to sort of rephrase it, global warming is a story of heating the ocean. And if it was only the atmosphere, we could stop putting it in more expensively, as John said, start pulling it out, and it would be over. But we've transferred the heat to the ocean, and as you know from high school physics or college physics, water has this amazing capacity to take in and hold heat. And that's what it's done. And it does two things with that. It expands the ocean, warm water expands, and that warm water is getting in places we don't want it, like around Greenland and Antarctica, and starting to melt ice because of the water. This is an attempt by Jim Hansen and others at trying to look at our global sea level, okay? And you can see until about 1930, sea level was rising at 0.6 millimeters a year. That's 6 centimeters per century rate. That's a little over 2 inches per century. Then in the 30s, we started to have the expanding ocean have a big influence and melting of alpine glaciers. And we more than doubled our rate of sea level rise to about 1.4 millimeters a year. That's almost 15 centimeters per century, which is 6 inches per century. That's the rate, okay? I think it's easier to think in that than millimeters per year. And then in about 1993, it kicked up again. The change in color is because we tend to measure global sea level rise now using satellites, which is very accurate. It's been challenged by the deniers, but it's very accurate. And you can see a kick up there, again, more than doubling. And that's because in the early 90s, the warmed ocean water started getting in around Greenland and Antarctica, and the warmed atmosphere started getting in around Greenland and accelerating ice melt. And ice melt is an acceleration process. And we more than doubled again to a little over 30 centimeters per century, 30 centimeters is a foot. And that now, if I update this diagram up to 2022, we're up to almost 6.6 millimeters a year. That's over 2 feet, over 60 centimeters per century. So this ice melt is really picking up speed, and that is how most people who study ice understand it, that it is an acceleration phenomenon, okay? That's the measurements of global sea level in the last century and a little beyond. Now, looking to the future, the U.S. government has put out projections that all the agencies, civil works projects have to adhere to. And in 2017, they put out 6 what they called scenarios, which are like projections. And the scenarios, I took off the bottom 3 because they're at less than 30 centimeters, less than a foot, less than 2 feet, less than a meter, 3 feet. We're going to be beyond all those rates. They're too slow to be meaningful, so I took those off. The higher 3, the intermediate, high, and the extreme, are the ones I have on. And they increase their rate upwards through time, and that's because we understand ice melt is an acceleration. Once it starts to go, it goes. And that's the understanding. The only thing we're still trying to learn is how fast that disintegration of ice can be. Okay? But you see that we could well, by what they call the extreme, which I don't think is the extreme, we could be at 2 feet in just over 20, 24 years. That's pretty amazing. And we could be at 3 feet by 2060. Notice on top I underlined global. This is an attempt at global sea level projection. Okay. Now, if we want to apply that to South Florida, Miami, we have to look at what regional influences we have. We're on limestone. We're not really. We're sinking geologically, but that's so slow you wouldn't care about it. So we're sort of sitting there. There are other places that are subsiding and sinking. And but we do have two things that are going to influence our sea level rise, and already are. One of them is a changing speed of the Gulf Stream. About half the Gulf Stream you see there goes north, and the Florida current, the Gulf Stream, and about half goes off to replace water that has sunk near Greenland. And that helps keep Europe warm. And that is slowing down because of excess fresh water melting out of Greenland on the surface. So in the winter it freezes, but there isn't any of that salty Gulf Stream water getting cold and freezing and having its salt drip out to the water underneath and having that water sink. As this Gulf Stream or Florida current slows down, as it flows north, the Coriolis effect, the Coriolis force in the northern hemisphere, turns anything moving to the right. So what happens in this illustration here, the water is going north, but piling up on the right side. The sea level in Bimini is a meter higher than in Miami. So and most of the water is over in the Atlantic Ocean, even though we have the Gulf of Mexico on the left side of this current. So if we slow this down, what's happened is we're going to raise sea level on the left side of the Gulf Stream and the Florida current. And that's not trivial. I don't even play live music. I don't want to play this song. You can get the idea.
Doctor, we can't hear you.
You can get the idea that it's moving. I think that's the only sound. Okay, and that we figure might be 15 to 25% extra to the global sea level rise, okay? And there's another one that's really important. And the first time I heard it, I sort of said, yeah, whatever. It's called redistribution of mass, okay? And this redistribution of mass it's like the moon pulls the tides around, right? It pulls our water around. It's far away, but it's a big mass. Well, the big mass of ice on Greenland and the big mass of ice in Antarctica also pull the ocean toward it, but it just pulls it toward it, and it's sloped, as in the left illustration here. As this ice is melting, there is less mass there on Greenland or Antarctica, so there's less pull. So the water starts to drop there, as in the right illustration, and go somewhere else. Now, somehow I couldn't get this to play, but you can go on and look at it's a NASA site that they have redistribution of mass and so on. And it just monitors the sea level change between 2002 and 2015, the time-lapse sort of sequence, month by month. This photograph, or this image, is from 2013. So this is the sea level change that has occurred to the ocean because of the loss of, especially on Greenland, of ice. And actually the sea level has lowered around Greenland like 5 centimeters, like 2 inches in that 11 or 12 year period. Unbelievable. And it's gone up. All this was sort of this neutral green where the 0 is on the bar on the bottom at the beginning, okay? It's unbelievable. So we've had a 2-inch rise in that 11 or 12 year period, 10 or 11 year period, just from that. And we were sort of incorporating about 20% extra to the global rise for our future projections. But Isabella Velikovna at the University of California in Irvine, who studies great science, she suggests the South Florida area should add an extra 52% because of this. This is a real thing. And so if you do that, if you take those things and you look at that global sea level rise projection, whichever ones you want to focus on, and you say, oh, I have to add 20% for changing speed of the Gulf Stream, have to add 20 to 50% for changing redistribution of mass as the ice sheets melt. You end up really just stretching this diagram depending what you want to do. The left side has 20 and 20% added. The right side has I think 15 and 52%. And you can see you go from what was 5 in the scenarios I show here, from 5 to 8.2 feet, you go to either 7 to 11.5 feet or 8.5 to 13 feet. These numbers are getting serious all of a sudden. Okay? And the problem is that ice melt is happening and it's speeding up. We're at the beginning of this, no question, but it's speeding up. We'll look at that in a few minutes. This is Miami-Dade County and Broward County above with 0, 2, 4, 6, and 8 feet of sea level rise. Okay? And I put possible times that we could achieve that. And as you look at the 0, the present topography, you gotta realize that at the king tides, I don't know what kind of flooding you have here. You must have areas that flood at king tides. And but this is Miami Beach with a king tide. That's what it looks like already. And even though that diagram didn't show flooding on Miami Beach yet, we're already flooding. In fact, you get king tide levels that equal numbers like 4 and 5 feet sometimes already, okay? So if we add 2 feet to this, we're gonna add, those king tides are gonna move up from 4 feet to 6 feet and so on, or 4 feet to 6 feet and so on. Okay, and so that's a reality. And this is happening at an increasing frequency. And I love this picture from Fort Lauderdale because it's like, it's not that rising sea level may happen in the future. South Florida's already had over a foot since 1930. Okay, so we're faster than the global average because of those two things I mentioned. And the other thing those maps don't show is, which is what several others talked about today, is hurricanes, storm surges. These are so critical. This was on the Boulevard Peninsula, just east of Galveston, where the Hurricane Ike, as a Category 2 storm, came ashore, wiped everything off except one house. Len and I went there about 4 years later. It was rebuilt denser than before because the FEMA money could only be used to rebuild there. I'm hoping they're going to change that somehow. I know it could be taken advantage of, but this is a problem. So as you're thinking, as others have said today, as you're thinking about the future and rising sea level, you really have to think hard about storm surges and hurricanes and maybe larger hurricanes. There's one thing that is really important to know here and on the East Coast. All these red starred areas are sort of areas where we have taken the coastal mangrove swamps, or we've taken the coastal Everglades like freshwater wetlands, and we have drained them and then dug up like this to get sediment so we could live on it. And almost everywhere, if you're along the coast, this has been built up to about 6 feet. And that was fine until sea level started rising and maybe bigger storm surges. But this is a huge area, okay? And I want to take you to Naples because I know some of you a few years ago thought global warming was a Miami problem. No, it's all of our problem. And here's Southwest Florida. Look at all the areas here that have dredge and fill, you know, to make enough land to build on. You see it everywhere. And if you look at Naples area with a 6-foot rise of sea level, you can see that that's exactly what happened. You're as vulnerable as we are over there. And now, we heard talks about 2 feet of sea level rise in the future and so on. Well, I've suggested to you we may have a much higher rate of sea level rise. If you remember those sea level curves with the higher rates, we could be at 2 feet within 20 years. We could be at 6 feet within 50 years. And that's not what's on any of our minds. It's not what's on any elected official's minds and so on. But this is what we're learning. We're modeling things as best we can. And, but we have to use our head with it. Michael Mann at the University of Penn State University is one of these people that is a great modeler, but also thinks about what it means and thinks beyond what the model is able to do. And he's saying things are happening faster than we anticipated. Let me take you into the past for a minute. You have to understand this if you're trying to look to the future. We don't put out weather forecasts by just looking outside. We have a hindcasting of years of knowledge of what happened under similar situations. Well, here's an example. If we go back on the left 120,000 years ago, we were in our previous interglacial. Sea level was about 20 feet higher. That's what Florida looked like. The Florida Keys were a living reef. We were a sand shoal. You had a few beaches and stuff around here, but it was pretty much sitting out in the middle of the South Florida Bahama-like bank. And then gradually we went into an ice age, and more rainfall fell or snowfall fell on our continents and didn't melt. So we lowered sea level over 420 feet. We had a huge ice sheet extending down into central Illinois. It was at a different time. And that was our last ice age. And it peaked about 18,000 years ago. Between 18,000 years ago and today, sea level rose 420 feet. It flooded our continental shelves, and that's where we are today. And the really important question that many of us have been looking at is how did we get from the middle diagram 420 feet down to today? And it turns out we now have data from every portion of it. And it all across the continental shelves are old reefs, old barrier islands, old coastal wetlands that were growing happily. And that's all the little horizontal bars on that graph. And then suddenly those reefs were just drowned out. That barrier island, that sandy barrier island was just drowned out. And a new one formed higher up. And these rises are of 1 to 10 meters. If you're not used to meters, just sort of multiply times 3. And those probably happened within a century or two. Again, the only way you can have a rise like that is to have an ice melt. That's the only thing that can do a global kind of rise. But we see these everywhere, and every one of those little pulses is a rapid disintegration of ice causing a global sea level rise. And then it sort of held out, and then another ice sheet sector went unstable and disintegrated. And that's the only guidance we have from the past is how the world's sea level works in a warming world in a time of ice. It moves as it pulses, okay? And that's really important. The sea level rise out of the last glacial period was a series of rapid pulses in climate. As climate warmed, the ice sheet sectors rapidly disintegrated. That's not in any of the models we're using to think about the future. None. And that's wrong. I just want to also show you that we can drill into ice, and we've done it in Greenland and Antarctica and all the high glaciers in the mountains. And they trap the atmosphere, and the atmosphere, as you get deeper in the ice, is these little bubbles you can see in the right picture. And those bubbles, we can go back and sample ancient atmospheres year by year in these layered ice deposits and find out what the CO2 was, carbon dioxide, find out what the methane was, and so on. Pretty cool. Well, here's 400,000 years of that. And you go on the left from 400,000 years ago. The red is the carbon dioxide concentrations. And you can see, and we could do this for 1 million years now. There's some over here, there on Antarctica, we've gotten much older. But what you see is every 100,000 years we warmed, and we got up to about 280 parts per million, and then we cooled down, got down to about 180. Warm, cool. Same thing for methane, which I don't show. And sea levels sort of behaved in concert, going up and down about 100 meters. Here's 100 meters, over 400 feet, in concert with that. So, and right up to now, we were down at about 180 parts per million, and then we rapidly warmed as we presented ourselves, as Earth presented herself to the sun to encourage warming. And CO2 built up, and we went up to 280, and sea level rose 100 meters. Since the Industrial Revolution, we have gone from 280 to 380 to now, this month, 420 parts per million. You know, if it was, I could say, this more than doubled it if we were at 380, but we're now at 420. What do you think sea level is going to do? Nothing? You might as well go stick your head in the sand and leave it till you drown, because that's what's going to happen. This is really, if you get this diagram, this is really eye-opening, really eye-opening to see what we have done, this great experiment, and how much ancient carbon can we dig up and burn. Yeah. And I have a little bit more I want to do, and I want to point out that we're going to continue warming the world's oceans because the heat's in the ocean, and it's going to expand, and it's going to keep taking the heat out of the atmosphere, and it's going to expand. And we are also accelerating ice melt in our alpine glaciers. Here's just an example of that, which is contributing to sea level rise, because that flows down. Here's a picture my dad took in '59, and 50 years later, Lynn took one. You can see a lot of those online if you're interested. The big thing, though, is we began ice melt on Greenland and Antarctica. And this just shows for two periods, 92 and 2005, how high the summer melt got up on Greenland. Greenland goes up to over 10,000 feet elevation. And when Lynn and I were in 2012 flying across, oh there it is, sorry, flying across to Ilulissat, out the window in July, everything was glistening on the whole ice sheet that we could see. Well, it turned out we were crossing the ice sheet during a time where it was unpredicted. We had the whole ice sheet melting, 98% of it. Okay? And that wasn't anticipated. Last summer, by the way, up in the highest part of Greenland, which is over 10,000 feet in elevation, they had a huge rainstorm that lasted at least 6 or 8 hours, I guess. But they don't know how much water, because there was no rain gauge. They'd never expected rainfall up at 10,000 feet on Greenland. So this is a changing world we're in, okay? And Greenland is one of the places that you must go to if you can. It's the most beautiful place and the most sobering place to go to because of what you see happening. Where Lynn's standing is, and go take Esther or somebody who has money so you can charter a helicopter. They're very expensive up there, but get yourself really out on the ice sheet. And but where Lynn's standing, the year before was under ice. That's the edge of the ice sheet. It's retreating so rapidly, it's unbelievable. but it's spectacular. And part of it's from surface melt from the atmosphere, and that meltwater goes down sinkholes, they call them moulins, and that goes down to the bottom and helps detach from the bottom the ice and the ground, and that then starts to move it rapidly, and then it fractures up and the water drains out. But it lets that meltwater into all the ice easier and gradually picks up the rate of melt. Notice the dirty surface. That's because all the Gobi Desert dust and the black soot, the brown soot that was accumulating in the ice sheet, as it's now melting because of a warmed atmosphere, is concentrating on the surface, which, if you've ever lived up north, you know black stuff absorbs heat and speeds up ice melt. That's what you try to do on your sidewalk. The other thing is that we're having the warmed ocean water now get in around Greenland and Antarctica. It started in the early 90s. And the warmed ocean water is salty, so it's denser. It goes in the red line under the fjord and goes deep in under the ice sheet, and it melts and sends cool water out. When we were up there, we flew in. This is a map of Greenland without the ice on it, and you can see the edge of the ice sheet is along where the blue begins, and we flew about 80 miles in on the ice sheet on a fixed wing. And what we were trying to follow the fjord of this fjord right next to it, that's under the ice, and it was like flying up the dry riverbed, meandering riverbed. It was just totally fractured, about 600 feet lower than the level of the ice. It was an unbelievable experience. But the reason that's lower is that this warm ocean water is getting in under the ice and doing a powerful lot of melting. I should point out the warmed ocean water is only about 2.5 degrees Celsius, but that can still do a powerful lot of melting. Same thing's happening on Antarctica. And there are, you must remember two places. The graph, the little arrow down in the lower right on the edge of the West Antarctic ice sheet, there are two outlet glacial fjords, the Pine Island Glacier and the Thwaites Glacial Outlet. The Thwaites Glacial Outlet is often called the Doomsday Glacier, and you'll see why. There's also a outlet, the Toten Glacial Outlet to the East Antarctic ice sheet. If all the ice on West Antarctica melted, it's a little over 25 feet of sea level rise. But we're not so worried about all of it, but we're worried about some of it. What's happened, and this is the same in Greenland as it is down here, we have ice jammed against the bottom, and often the weight of the ice inland has pushed the land down as it's in contact. So there's often this retrograde slope going inward. But that's sort of what it looks like. And then all of a sudden you get warmed ocean water coming in, which we're getting around Antarctica because of increased winds around Antarctica. And that warmed ocean water is starting melting. And in 2009 was when they first put a gadget, a remote gadget going in under the ice. And it went in about 25 miles. A decade ago, they knew it was solid to the bottom. It went in about 25 miles. And that was because this warm ocean water is getting in and melting. And then coming out mixed with fresh water. And this continues to happen. And this is happening at a pace, as you'll see in a minute. It's very frightening. This is just a similar thing from the Thwaites Glacier that's in a journal publication, just so you can see that's what it's. The interesting thing is, once it detaches from the bottom, the ice, there's nothing to hold it. So, and under tension, ice breaks apart very easily. And so you can have this dynamic thinning. It's sort of like a stack of books on the table that suddenly split out, right? That's exactly what happens. And what they're deeply concerned about now, and this is really, really important. At the American Geophysical Union meeting last December, there were a couple talks saying that they think that the Thwaites Glacial Outlet, the ice will detach from this ridge, topographic ridge, within 3 to 5 years. And once that happens, the area inside deepens quite rapidly. There's really nothing for the ice to jam against. And so if it's detached, it will start splaying out, breaking up, shedding like the books. And they suggested that we could have a very rapid 2-foot rise of sea level because of this, followed by another 8 feet because of everything behind it. When the ice is free, that's what's holding everything back. And once that's gone, this could and will just start letting everything come free quicker. So if you want to keep your eyes out in the newspapers and online, just keep looking at what's happening with the Thwaites Glacial Outlet, the Doomsday Glacier. It really is one. And the meltwater coming out is not going to slow that warm ocean water coming in. That's deep enough that it'll come in. And that's just that 2 feet, just from the collapse of the Thwaites Glacial Outlet. And that eventually another 8 feet. And at this point, I have to notice that right in this month, the U.S. government is coming out with a new projection for sea level rise, updating the one I showed you earlier with the 3 scenarios. And what they have done, it's a group of modelers that doesn't look out the window, I think. And no, I'm serious. And I had to get off the Miami committee on with the compact looking at sea level rise because they were just hiding behind their models and not looking. But they have taken off the extreme, and they have reduced from, what is it, Mike, 17 inches by 2040 to 11 inches. Yeah. Is that right? And what they're doing, there's not one reference to any of the scientists working in Antarctica on what I've just described to you. There's a group called IMBY, if you're a scientist and want to look at it, look up IMBY. It's a group of 80 Antarctic scientists that are writing what's going on down there. And it's very much a collaborative effort. And so that's a problem. And so I would highly recommend that you take this recent projection with a grain of salt. They're being very, very irresponsible and unhelpful to communities that are trying to protect you and for the future. And believe me, communities don't like anything that will hurt their tax base, so they will probably latch on to it. But you're aware that this is a real problem. Okay, and so that's what's going on. And in Antarctica, it's still mostly below, from below with the water. It's still a little cold to have atmospheric warming, though we are getting rainstorms coming in, what they call atmospheric rivers, where it just shoots a lot of water-laden air over Antarctica and it's causing major melting from the surface. So this summary is of this, that reinforcing feedbacks make a future of rapidly accelerating ice melt and accelerating sea level rise, I think, inevitable. We've warmed the ocean, don't forget that. And it's going to be faster than you want and than anybody's anticipating, I think, or most people are anticipating. On a little short time, so I just want to point out that Jim Hansen back in 2012 projected we could have a sort of Ponzi-style disintegration of ice, doubling the rate every decade, and we could well be at 5 meters, that's 17 feet by 2095. That's real. And the modeling scientists that don't look out the window, they have been like little chihuahuas nipping at Jim Hansen's ankles for years, and he keeps putting out follow-up articles reinforcing what he said. It's pretty impressive. The amazing thing is that we're running, he said if we were at 1 millimeter per year average in the 2005, 2015, and then double. The amazing thing is we're running ahead of his projections just looking at Greenland. And again, I'm not, I can back up in questions and go through the slide, but you can see the mass loss on Greenland is happening and it's steepening downward. And we were at 1 millimeter in 2010. And we had doubled our previous rate 7 years before. It was less than half a millimeter. So I think rather than worrying if we're going to be at 1 foot or 2 feet, 2.5 feet, I think you ought to realize from what we have done, this massive increase in CO2, that we're going to go into a series, probably a series of pulses of ice sheet disintegration and sea level rise. And these could be 1 to 10 meters. They could be a couple of them. And when you see what we've done, and as a couple of the previous speakers said, it takes time to have a response. But we could well be at 30 feet, 90 feet later on. Yeah. And, you know, right now, where are all our national treasures? They're in the Smithsonian. Did you know the basements of the Smithsonian Institution are flooding regularly? That's our national treasures. Why haven't we moved that? It's unbelievable. And you can start asking about all the things that you don't want to lose. Maybe even your model train set that you've worked so hard on. Whatever. You know, but this is really fundamental of what we should be doing. And the other thing is we're going to lose our deltas. Our deltas are a massive food source for the nations that have them and beyond. And we should be planning to replace that, not for the next people to do it. We should be planning for that, okay? So what I tried to show you today is our coastal future and fate is at the mercy of the dynamics of polar ice. And I'm not convinced that that's going to hold up very well in the future. We should be planning for a challenging century in which other things we down here will be moving on. These maps are from Peter Harlan, who just died, unfortunately, but he made these wonderful maps looking at peninsular Florida, and they're very sobering because, again, he has them at every foot, and I'm just showing you. Here's 8 feet. It's over for us down here. It's over for Naples and Sanibel and a lot of other areas. Just the first feet that will happen in the century, as far as I can see. There's 16 feet. This will happen too. The thing coming down from the north is the St. John's River Valley coming down here. Okay. And here we're at 24 feet. And it's absolutely changed Florida. And I want to do a close-up. Here's close-up for our areas. Here it is with 8 feet. Here it is with 16 feet. And here it is with 24 feet. And then I want to show you where we live. Compliments of the lights. Enjoy it while we got it. You know? So we have a choice of making this a progressive, orderly process in which there's honest planning and help for the affected families, communities, businesses, and never talked about, cleaning the land before inundation. Or if we don't, we risk catastrophic chaos. Go read about the Dust Bowl. Creation of huge numbers of dislocated indigents, polluted wetland and marine environments. The choice is ours. Thank you very much.
Well, we knew a lot of this information. This is really not a surprise. We heard a concerted message from Mike and John and Hal. And I guess the question is going to be, what can we do about it? Is there anything we can do about it? But I'm going to turn the floor over. Mike and John, would you come up and we'll just see, if anybody has questions for any of the three of you. Yeah, Mike, if you want to come up too. Yes, sir.
Al, what was the source of CO2 in the earlier eras when the warming occurred in that cyclical graph that you had? What was causing the warming and cooling then?
Yeah, it's interesting because it's how our orbit around the sun is more circular or oval, how much
Like
warming we
cycles?
get. And then there's a series of things that happen as you warm, including weathering and including various aspects of productivity, both producing oxygen and decay of materials. And all those reinforce as we do a little warming to encourage more warming.
So carbon dioxide can be either a leading indicator or a trailing indicator of the energy budget of the planet, but they're correlated.
When
Points disintegrates and you start now taking off the roadblock and we're going to start seeing a much faster rate of melt. When you say faster rate of melt, I mean the disintegration, I guess, could start occurring in 3 to 5 years. So when will, because that would give great validation in one step that all of these models are totally too optimistic. So how fast will we see that occur?
Well, I just showed you that the scientists studying the Thwaites Glacial Islet are saying that could detach from the bottom within 3 to 5 years, and that, they say, will lead to a very fast.
But over when you say very fast, are you talking?
Probably over a decade or less. I don't know.
So we're going to have
We have never witnessed how fast ice can melt in our civilized existence on Earth as humans. You know, it happened, but we have really kicked the bucket. I hope you appreciate how we really kicked the bucket over. You know, the last 100 parts per million of CO2.
We can't hear any of this.
The last 100 parts per million of CO2 that we put in has gone into the atmosphere in the last 60 years. That's 200 times faster than the natural fast rate that we were talking about. And that takes time. By the way, CO2 stays in the atmosphere for about 4,000 years. To put it another way, Ben Kirkman at Miami says every time you go out to the store in your fossil fuel burning car to buy a loaf of bread, whatever you put in the atmosphere will be staying there for 4,000 years. Now you will feel guilty all the time.
The chart that manufacturer referenced about the change in the CO2 level, I only could look at it for a moment, but it looks like it took 1,000 years for it to go up and 100,000 years for it to come down. You probably know that.
Well, it's about 10,000 years to go up, the natural. And then, yeah, we warm somehow, usually very fast, and then we work our way down into an ice age.
That's about 100,000 years, right?
Yeah.
Okay, I get that. But then what we've done is we've doubled, your projection shows a doubling the concentration of CO2 in a very short period of time. And you also made reference to the sea level climbing going up around Florida relative to the Gulf Stream stopping. But if the Gulf Stream stops, water level isn't going to make any difference anyway, because that's going to be an absolute catastrophe, because it's a heat pump to get the heat out of the tropical area and move it up north.
Part of it goes off to feed the sinking water near Greenland, and that's what keeps Europe warm, so they can live there.
Right.
And 12,000 years ago or so, this stopped for another reason. as we were coming out of the last ice age. And within a decade, Europe was in a little ice age again.
Right, right.
Now-
Are we able to get rid of the carbon that's in the atmosphere in time to save ourselves? I mean, the Russians made a deal last week with the Chinese to buy 100 million tons of coal.
Yeah.
You probably know that as well.
Yeah.
I don't know how much 100 million tons of coal does to the percentage of CO2 in the atmosphere. I don't have any idea. But I do know what we're doing with some of the decarbonization things. Like China has more electric vehicles than we do.
Yeah.
All they've done is move the coal power plants 200 miles away from Beijing and Shanghai to burn coal over there. They're not using less, they're burning more.
I know.
They're burning more. They're not doing anything. And the gearboxes that we're using for the wind turbines are horribly inefficient, and they don't run right. And they're made in China in foundries that are filthy with coal.
You need to take charge here. I mean, we're not doing much of anything right, and we elect Biden, or somebody elected Biden.
Doesn't matter who it is.
Well, just a minute, and well, we're all going to make it better. Well, all of a sudden we have a cold winter. Oh, we need more gas now. So nobody's doing anything.
Well, actually, I disagree on one level because
Is
hydrogen,
that a question?
hydrogen might be the way out of this mess.
Hydrogen might well be the way out of this mess. I have a friend, Tim Dixon at University of South Florida, that wants us to be making hydrogen in Iceland using geothermal energy. But it takes energy to get it, and then ship it everywhere.
Really good questions. We need to give the lady in white an opportunity.
Are you saying that the Gulf Stream, where it goes up by Nova Scotia towards Greenland, is not going in the same direction as it always did?
That's right.
Where does it come up? Because Nova
Well, less of it's going up.
Scotia...
Less of it is going up. There's more fresh water on the surface around Greenland, and so that freezes in the winter, but it doesn't sink because it's just fresh water frozen. It depended, the whole dynamics of bringing more water every year is because the surface water of the Gulf Stream is very salty and warm. Gets up there and gets cold, top freezes, salt drips out of the ice, so it doesn't want to be in there. And the remaining water becomes super salty and sinks. And that goes down to the world's oceans. It takes about 1,000 years to go down and over the Pacific and back up as a surface current. And that's slowing down. And that...
It's warm enough to keep Newfoundland and Britain warm.
Just watch. Just watch. Wait a few years. You'll probably see some cooling.
There's no doubt that we're into a glacial supermax, and it's getting warmer. But I have a couple questions. One of them concerns the level of carbon dioxide, CO2, that's in the ice cores that are drilled into the ice sheets in Greenland. And when you look at the ice cores, they have little bubbles in them. But every 100,000 years or so, if you're measuring, there's a melt layer in those ice cores that are clear, and they don't have like bubbles in them. And those are the warmest levels at the end of an ice age or an interglacial period.
Okay.
Because they're clear, they can't hold any bubbles. So we have no idea what the CO2 levels are every 100,000 years and how high they are.
I think we have that from Antarctica now because it doesn't get much above freezing.
Well, the temperature right now, what happens though is that the temperature right now in Baffin Island this week is about 41 degrees below zero. When you have an ice melt, that area will freeze, and it takes a lot longer for the ice to freeze. So that's my first question. What are like three questions really? What is the highest greenhouse gas we say CO2 is a problem, but what's the biggest greenhouse gas? The biggest greenhouse gas is water vapor.
Water vapor, right.
Water vapor, which is the highest percentage.
That's correct.
The other question I have, this is the most serious question of the lot, and then I have a statement too, is that right now the ice in the Arctic Ocean is melting from the east to the west, really from the west to the east. I say east, I say China. But it's melting basically from Russia and China towards Greenland. Why is it doing that? That's a very serious question. The second thing that's happening is in the last few years, you can look, there's an article by Frank Leslie, who writes scientific, he was a senator in Wisconsin, and he's writing, and the levels of the snowfall levels in Greenland in the last few years have been increasing. And why are those increasing? The Arctic, I can tell you the answers for those things, but why are they increasing? And I'd like to know your opinion on those things.
The increase in snowfall in Greenland is partly because of increased open water, sort of like the buffalo effect. Where you get
Well, I had right now, the Arctic is basically like a desert. It gets about 10 inches of precipitation a year.
Right.
Okay? With the Arctic Ocean free of ice, there's going to be a mammoth increase in precipitation.
And what they're finding is it may well be a lot of rain too. So,
Yes, but
and that's a
freezes,
powerful
but
melt.
when it freezes, it takes a lot longer to melt when it freezes. And those are those melt layers that you have in the ice cores.
I think we've overwhelmed it this time. You're very knowledgeable. I appreciate it.
Yeah, thank you.
I've got a whole thing that I've written on this because we can probably stop the ice age from coming, but we're going to have another ice age. Whether we're flooded or not, if we don't stop it, we're definitely going to be flooded. The methane that's being produced right now in the Arctic through the melt is unbelievable. You can see the methane that's coming out of the rotted. They're producing
out of the
more
permafrost is melting,
than anything.
and out of the methane hydrates. Yeah, I have a big talk on that. But
So we can't, right now, there's no way, no matter how much carbon we hold back, over the past 400,000 years, we've had these repeated ice ages over and over and over and over again. We might be speeding up the ice age coming, but there's another ice age that's going to come, and we're going to be flooded out before it comes.
The driving force from the orbit, from circular over, is very subtle now. It's a very weak driving force to put us back in. And we've overwhelmed the system, man.
Yeah,
Period.
But we have maybe we're increasing it, but we really aren't changing it. That's the key that my feeling is that we're not really changing it.
I think you need to look at the ocean, that we have warmed dramatically, not just the top 5
If you
feet.
look at the ocean currents, and there's a study, a French study that's done on the ocean currents in the Arctic Ocean, and which are the top ocean currents and which are the lower ocean currents, how cold they are and how warm they are. And basically the Arctic Ocean, anyway, I've said enough.
And we've warmed the ocean, and that's why we can't turn this around. And since the carbon dioxide is staying in the atmosphere, just let me finish, till we pull it out. That is going to keep warming the ocean, because it's going to stay warm, and it's going to keep warming the ocean because it's turning over and warming it more and more.
We can't pull it out, we can't stop it. It means we're going to go into a flooded area, and then we're going to start another ice age. Is that correct?
Possibly in another
It stays
20 or 30,000
CO2
years.
stays in the atmosphere for 4,000
Because
years.
when an ice age starts, the start of each of the ice ages, when you look at the Arctic, the start of each ice age, you see trees that are growing around the Arctic Ocean. It's always warm at the Arctic Ocean at the start of another ice age. And the progression of trees to the north has been geometric because it's getting warmer.
Yep, I know.
But
Let
when
someone
you
else
trees
have a
in-
question, please.
Yeah.
Anyway.
I'm really impressed with the knowledge we have in these two gentlemen and in general in the room. So appreciate that, and we should try to keep the conversation going online, maybe by email. Yes, ma'am.
How do we capture carbon?
Well,
Mike says.
How do we capture carbon?
there are a lot of ways, and we're working on it, and go ahead.
Well, I'm supervising a graduate student at the University of Florida now, and
he's working on what's called carbon farming. And that's an attempt, it's also often referred to as regenerative agriculture. Global agriculture has grossly depleted the carbon stores in our soils. And alternative practices can help reverse that to where the soil again becomes a carbon sink from the atmosphere. But as Dr. Wallace pointed out, you've got the ocean as a repository for not only the heat, but the carbon dioxide. So you have to extract it by reducing the concentration in the atmosphere, by moving it into the soil. Then it diffuses out of the ocean water, and so you have to continue that process. So it's a huge effort, but one of the key technologies is carbon farming. And that isn't necessarily energy intensive. I talked about energy intensive methods. This is an intellect intensive process. And it also requires a deviation from our current extractive approaches to industrial agriculture or industrial anything, because there are practices where you can grow biofuels and have it be effective. But a corporation gets a hold of that and they say, wow, if that's valuable, then I'll just dump some fertilizer and irrigation on it and I'll get even more from it. Well, you completely negated the energy budget on it. So there are intelligent ways to do these things, and there are false ways, greenwashing ways of doing these things. And that's why the ecological economics and the carbon accounting programs that need to exist at every university are so important, because we need an honest scorecard on what works, what doesn't, what value we're getting from our investments.
Thanks. The carbon capture question got me thinking, and this gentleman who I guess stepped out had me thinking about another matter. You know, the problem here is, and you could hear it from that gentleman's questions, and you could hear it from Hal's response, you know, to get governments around the world to coordinate their activities to reduce our carbon footprint is probably an intractable solution. I mean, it's just so difficult for humans and societies to collectively do what's necessary to reduce the amount of carbon that's going into the atmosphere. I'm not saying that those efforts shouldn't be attempted, and I'm fully supportive of what COP does in trying to bring countries to the table and agree to meet target reductions in carbon. But something has to happen simultaneously. And the person that asked the carbon capture question, for years I kept thinking, you know, technologies to scrub carbon dioxide from the atmosphere are probably too unlikely to ever be economically sustainable, or to be greenwashing and require, as John had mentioned, requiring more energy to develop the technology than actually have it create a net loss. But I think differently now. I believe that given the inabilities or the ineffectiveness of government to handle these problems, regardless of the reason, kind of necessitates an alternative strategy. And from my perspectives now, developing those kinds of technologies should be pursued vigorously.
Yeah.
And then at the same time, you know, Hal's scenarios, they're scary, and that they could only be scary. And they're also real. Admittedly, there's some variability in how bad it might be, but regardless, it will be bad. And how do you deal with government and communities? How do you allow them or give them the drive to work towards dealing with the problem, at least over an interim period of time, to deal with a situation that is truly adaptable when the final Armageddon scenario is so horrific? And so what I think is necessary here is that local governments should genuinely address adaptive needs over the short term. Maybe the kinds of changes that Hal is talking about are adaptable to about 2050 or 2060. Maybe the technology to scrub CO2 will exist then. Maybe governments around the world get their act together and collectively work on reducing their carbon footprint. But at least we're proactively working towards solving the immediate problems. And then, at the same time, what communities have to do, and communities aren't willing to do because it's too damn scary, is they have to talk about managed retreat. Okay, when you look at those maps that Hal showed, you know, there are communities that are going to have to pack up and move sooner than you might think. Everglades City is really 10 years away from needing to manage its retreat from the coast. That's our own community, one of our own municipalities. And managed retreat is taboo. Nobody wants to talk about it. So my grand, you know, if I were, you know, king of the forest and I could influence, you know, people's thinking and behavior, I would keep hope alive, deal with adaptation over the short term, okay? Make sure that we have sustainable, livable communities until 2050, 2060. Hope governments get their crap together and come up with a plan to reduce carbon dioxide. Invest heavily, nationally, internationally, on the technology to remove carbon dioxide, and at the same time, develop those plans to deal with moving people across the landscape in a civilized, non-chaotic, non-threatening fashion. The chaos that Hal referred to, you know, creating an additional environmental holocaust, if you will, simply because we weren't able to manage that retreat, just makes whatever generation follows life existence that much more difficult. Sorry, I got on a soapbox.
That was really interesting. So there's an important report coming out at the end of in 6 days, the IPCC report on adaptation and sustainability. And they deliver these reports every 6 years. There's going to be a lot of information that drops just next week. And it will not be good news. We have advanced indication. So I want to let Hal address that question.
I want to address your question. And Elon Musk has offered $100 million to people that figure out how to meaningfully remove carbon dioxide. And at the Glasgow meeting, part of that was to go to students, 10 million of them. And one of our students that was in my class, I gave a brochure to last spring, and she applied, and she just got $100,000 at the Glasgow meeting for that. So, but how do you remove carbon dioxide? That's what all these people are working on. And there are active ways and passive ways. One of the interesting passive ways is that, you know, the black lava basalt, you're all familiar with it? Yeah. A lot of very reactive minerals. If you grind that up and put it on your farm or your garden, that actually uses carbon dioxide in the weathering process. And so one proposal is to grind up lava and put it everywhere, as it has a lot of nutrients in it. Do it carefully, because you have to watch the acidity and all that of the soil wherever you're growing. But it could become a very powerful tool. Already, Iceland is bubbling CO2 charged water, which is not hard to come up with, through the lavas there, and it's precipitating out calcium carbonate, taking the CO2 out of the water. So there are a lot of things going on. And if you have a creative idea, run with it.
It's going to take a private-public partnership. So you know, a lot of these big corporations are going to get involved. You got to be very wary of them, because they're going to get on the coattails of this greenwashing thing. But there's a lot of money. There's a lot of private money out there, and if properly positioned and stoked, that can help solve the problem.
The $100 million is great, $1 billion is great, but if we were treating this like the threat it is, like a World War II level effort, a time at which we were spending 33% or more of our GDP on that war effort, we'd be spending $7 trillion a year to address this problem right now in this nation. And we're not even, you know, we're a couple of orders of magnitude below that right now.
I first want to start by thanking all of you for spending your life, passion, researching all of this and never giving up. But my question to you is, America is one of the biggest carbon polluters, and our federal government doesn't seem to recognize it. None of the presidents do. Do you feel any president and how we as people can vote or campaign to find someone that would stand up to this? Is that even a possibility?
You have to, what we have to do is get a critical mass that is not Republican or Democrat, but people that demand whoever they vote for get heavily involved, $7 trillion a year or whatever, in climate change, solving it. This is a huge problem. And that's why I put this thing up on the board here.
I'm active in the Democratic Party. I've served as the state science officer for the Democratic Environmental Caucus. But even in that form, I tell them I'm simply a Green Party insurgent within the Democratic Party. Because you would have to change politicians 3 cycles in a row before they would realize that the voters are serious about addressing this or any other issue. Because they depend upon your loyalty once they get elected. So they don't really have to address the fundamental issue because of the other biases in the system. You have to change politicians several times in succession and gradually build in the type of action individuals that we see.
And a lot of people running for office talk of a good thing, and then nothing happens. And we've seen that, Republican, Democrat. You've seen the effect it has globally on this thing I have up on the board. It just keeps climbing and accelerating. And we have to do something different and something more. Yeah, we'll go over here from there.
I just want to say that's because corporations are running the government. And until this becomes economically viable for corporations, nothing's going to happen.
Well, the reason I put this diagram on the board was twofold: to see that nobody's done anything, and globally, which is hard to do. But back in '81, I think in the Carter administration, they for the first time, the U.S. government said, "Is this real? Is this serious? How urgent is it? Can we do something about it? How hard will that be?" And the answers were, "This is real. Yes, this is very serious. Yes, it's going to be very hard to solve it, but we should start now." And so in '81, the green line there, that was the first time we asked. And CO2 was at 340 parts per million. If you go back in our geologic past a couple million years to see when we were last at 340 parts per million, we were at 10 meters sea level rise. So that's where we're headed before we even asked the question. And then in, 2015, when Obama was president, we passed 400 parts per million. You go back and look, last time we were at 400, we were at 21 meters, 70 feet sea level rise. So that's where we're headed, okay? That's not anything fancy, but, and every year it's getting worse and worse and worse. Yes, sir.
Thank you very much for coming. It's very enlightening. I have a question getting back to the ocean temperature rises. Because, and I know
Can
that
everybody hear?
Can everybody hear? Anyway, just about ocean temperature rise. Might that even be more dangerous, eminently dangerous in respect to phytoplankton and other things that are producing 50 to 80% of our oxygen on the planet in terms of that? What are the...
So what he's edging at is the ocean is being subjected to increasing heat, increasing CO2 going in, which is making the ocean more acidic, and making it more difficult for corals and other little plankton that calcify to make their skeletons. And over half of the air we breathe doesn't come from the trees, it comes from the ocean, from the phytoplankton. We are totally indebted to the ocean to have the oxygen levels we want. And there's, in fact, concern that if we don't get hold of ourselves by the end of the century, oxygen levels will not be high enough for animals to live. Birds will be okay. And and we're a mammal, by the way. So we have to get hold of this, you know. There are other things, you know, we left the Stone Age not because we ran out of stones. This is time to move on from this. But you can't do it by just cutting it off. You have to put an alternative for people to not freeze to have enough energy to cook and I guess get around and all that.
So folks, we really have to kind of wrap this up. It's been an amazing discussion, and we're sort of in the education awareness building phase here. So you are now ambassadors, you're now imbued with this knowledge from Mike and John and Hal, and I hope you will go forth into your communities and talk about the urgency and maybe keep circulating the information. You know, we have all your emails, we will contact you. There was a lot of great information that came from the audience and good questions. So we encourage you to stay involved. We've still got to figure out what we can do. I don't think we've answered that question. So, and that's maybe another half hour. Two things, we talked about the acidification of the ocean and the warming of the temperatures, which is affecting coral reefs. On the 29th of March, we're going to have Marissa Carozzo come here and talk about how our reefs are in danger from all those pollutants, eutrophication, acidification of the ocean and bleaching and whatnot. So please, if you're in town, come back March 29th. April 23rd, we're going to do a fairly massive Earth Day event called Save Our Planet Climate Change Jamboree, and we will be federating agencies, nonprofits, city officials, state officials, churches, enterprise zone and renewable energies, family zone. So it'll be quite a ambitious event in Cambier Park, right next door, on the 23rd of April. So that's what we gave you the sheets of. So let's just keep the conversation going. We got a good start, and these are problems that we have to tackle now. So I want to thank you for coming. I want to thank Mike Savarese and John Capis and Hal Wallace for coming and sharing their thoughts with you.